Hi everyone and welcome. Today we're going to be looking at independent and dependent variables of functions as well as evaluating functions for specific values. So your goal after watching this video will be able to understand and identify independent and dependent variables and additionally to evaluate a function at a given point. So to start us off, another real world example of a real function. So moving to Ohio, saw some of these speeding fines were kind of surprising. Now, obviously I wouldn't know from personal experience or anything like that, but in Massachusetts where I grew up, speeding tickets were pretty expensive. So no matter how much you were speeding, if it was, half a mile an hour over to 5 miles an hour over, $100 minimum fine. And after that, after you hit 10 miles an hour, it goes up by $10 per mile an hour. So for example, 10 miles an hour over, $100. 11 miles an hour over, an extra $10 on top of that. So 110, all the way up there. So if we're looking at speeding tickets and getting pulled over, well, in this context, we'd be thinking about it in terms of independent and dependent variables. So independent variables are what do you control? Well, you don't write the law, but you do determine how far your foot goes down on that pedal on the right side. So thinking about it like that, you get to determine your speed. And your speed is ultimately what gives you the fine. So your independent variable in this case, I forgot to hit the little right function there. So independent variable is what you control. In this case, that's speed. Dependent variable is basically it's your output, what's given to you. So based off of your speed, the officer kindly goes in, punches into his calculator and sees what is your fine, or how much do you have to pay for that ticket. So again, thinking about it like that, you're not telling them, hi officer, please write me a ticket for $0. It goes the other way around. He's like, well, based off of your speed, which you controlled, I will now give you a ticket for this amount of money. So important context to understand the cause and effect here, what's starting this, and the thing that you control, this thing that starts it, that's the independent variable. And again, speeding is a good example of that because you control the speed of the car. Quite a few other examples out there, though, where, again, you are controlling that input or the independent variable, and you are given something based off of the value of that input. All right, so starting off first, looking at these in terms of functions. So function is our word today. This is a relationship where each input has exactly one output. So again, in terms of this, it's, what you control. So for example, if, I'm going 5 miles an hour over, the output is a $100 ticket. It's not like, oh, it could be 100 some days and 200 on other days. No. In the United States, we are, as much as we can be, we are, clear. There's no corruption in terms of that, in terms of, you're not going to give somebody cash to pay them off, right? It's the same fine no matter what. So that's an example of a function that works. There's only one value for 5 miles an hour over. There's only one value for 10 miles an hour over. It's not different depending on the day. It's not different depending on who you approach. Something that wouldn't be a function is like, some days 5 miles an hour over it costs you $5. Some days 5 miles an hour over costs you $100. So again, each input, only one output. And if we're looking at this in terms of, again, our two different input and output or independent and dependent variables, we can see that here when we're taking a look at our tables. And before we go on, I also actually want to define our second word here too, because I think it's going to be helpful for what we do next. So independent variable. And this is the input or variable we control in a function. And again, from the example to start off class, you control speed. So that is the independent variable. All right, so now let's take a look at some practice questions here. So first things first, I want us to list the inputs and outputs. Well, typically, if we're looking at an input, that's going to be your x value, almost always. That's what you put into the function, and it spits out the output or the dependent variable. So inputs for our first one, 2, 4, 6, 8, and 10. Outputs, we have 7, 9, 11, 13, and 15. Is this a function? Well, do we have any repeating inputs with more than one output? So for example, if we have 2, Do we have multiple values that could come out based off of x being 2? Well, in this case, no repeating inputs. So is this relationship a function? Yes, it is. So that's the idea. We can do that for the second one as well. Look at the inputs, look at the outputs, see is it a function. Next, we can take an example of Spencer. So Spencer's going biking every morning. If he bikes more, he's going to drink more water. So what does he control in this case? So again, if we're looking at this here, what is he directly controlling? Well, he gets to decide when he starts or stops his bike. And based off of that is how much water he drinks. So he's not necessarily directly controlling the water. The water is a function of what he does biking. So if we're thinking about this here, independent or dependent variable, well, the distance Spencer bikes, that's what he controls. That is his independent variable. It's his input. His dependent variable, water depends on what he drinks, not the other way around. It's not like, oh, he drinks water and then magically he starts biking. No, it's he's biking and then that makes him want to drink water. So again, it's the biking that causes the water drinking. So again, thinking about cause and effect, the order in which these things happen. Secondly here, a couple different ways that we're going to see evaluating functions. So first things first, if we see notation like this, f of 2, well, f of 2 is saying when x equals 2, or when Mr. Reardon eats 2 bags of popcorn, how much does it cost? What is our output? So when our input is 2, our output is, well, input here is 2, output is 10. So again, no real solving here. We're just looking for, okay, based off our input, what is our output? Well, sometimes we don't know our input, but we do know our output. So in this case, they give us the 10 first, and I'll do this in a different color. We're given the 10 first, and we go backwards. So we see when the output is 10, or when it costs $10, we know that Mr. Reardon is buying 2 bags of popcorn. So that gives us our input value. So we know our input is 2 if our output is 10. So a little bit of practice there for evaluating with tables. Again, no calculator work needed there. Just literally looking at the table, what's the input, what's the output, trying to match them up. The last thing, we will need some calculator work here, is our input is -4, and we're trying to find, based off of that, what's our output. So everywhere that we see an x, we're going to replace it with our input value, or our -4. And then we just follow PEMDAS like we did at the start of the school year. So -4 times -4, okay, positive 16, minus 16, because 4 times -4 is minus 16, minus 1. Well, all that together just gives us an answer of -1. So again, that's what we're going to do for the rest of these questions too, and that's your job to plug that in right now. Again, everywhere that we see an x, we're plugging in that input value, and then we are evaluating to see what is our answer when we do that. All right, team. So as always, appreciate us tuning in. Save those questions if we got them for small group time. We will definitely have some time to go over them in class. Also, feel free to email or message over anything that you got. We'll answer as soon as I possibly can. Again, thanks everybody for tuning in. I'll see you all in class very soon.